that we're actually looking at talks about polynomials. And that's going to involve starting with quadratics. And then we're going to go and look at cubics and quartics. And you're thinking, what on earth is she talking about? Well, hopefully you remember a little bit. Quadratics. Anybody? Anybody? What do they look like? Yep.
I believe the formula for a quadratic is x equals -b.
Oh, he's even got the right. So that's when we're solving. So what would the shape of a quadratic graph look like for starters? Tom at the back. The shape of the graph, my friend. Yeah, Ed. No. Yep. Yeah, you're doing it with your hand. Right, so they look a little bit like this. Parabola, right, or like that. And there's another key word. I have to say parabola, parabola, so I can spell it properly. Right? So we see that. Now, we can see them around the place where the good old Macca's signs, that's a parabolic function. You've got bridges, it's used in architecture a lot of the time. And of course, projectiles, right? What goes up must come down. So quadratics are used quite a lot in real life. You also will have situations where you'll be finding the maximum of something, or the minimum. And so we're going to be using our algebra to try and help us solve those sorts of things, okay? And yes, we're going to use our graphics calculator to help us also. It extends to cubics, where we know quadratics have the form, the general form, y equals a, x squared plus bx plus c, right? And I have to put a doesn't equal 0. Why do we have to put that? Because what would happen if a was 0? Then it becomes linear. It's not a quadratic anymore, right? So nothing fancy there. It's just saying we want the x squared involved. Yeah? With cubics, it's then going to be ax cubed plus blah, 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 blah. And with a quartic, you'd have to write this bit down. Don't bother. Right, that's going to be x to the 4. Plus blah, 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 blah. Your investigation that you're going to do for this unit is going to be revolved around quartics, and a lot of it will just be using software and your graphics calculators, okay? But before we get to all of that, what we have to try and do is come back and remind ourselves how we solve quadratics, okay? Can anyone remember some of the options that we've got for solving quadratics? Dylan has mentioned one. What did you say before, my friend?
I mentioned the formula for solving it is x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a.
Oh, jeez. So, wowza. So, what we want to focus on today, and you're going to on the weekend, is solving quadratics. Now, Dylan just mentioned, and you don't have to write this bit down if you don't want to, but Dylan talked about solving using the quad formula. Now, this will work for every single quadratic. Is this flashing back for some of you from last year? Little bit? Who could say they've never seen it before? Yep, good, that's fine. A couple of people, excellent. And it's not a bad thing because you're thinking, oh my God, all these letters everywhere. But Laurie, what are all these letters coming from? Yep, so there's your A, there's your B, and there's your C. So A, right, we're going to call that the leading coefficient. I'll write that later. B is the coefficient of x. C is your constant term. Jasmine, what are you doing? No, you're not. Remember what we talked about? Let's help out. So that's one method that we're going to use for solving. In fact, there's actually going to be 3, but anyway, 4, yep. Excellent. So that, finding the product and sum, that is what we're going to look at this morning when we look and remind ourselves about factorizing. There's one other way that we can solve, and that method, I do this too. Completing the square. That's right. So completing the square, for those who came on time, yes, that was one of the things we said this morning. And I actually did forget, but we do have our graphic calculator, absolutely. Okay. So what we're going to focus on this morning is going to be factorizing, and hopefully, although it might be pushing your luck a little bit, hopefully we'll get to completing the square as well, but we'll see how we go, all right? Don't want to scare your pants off. Right? This is just the steps in factorizing. What should you then do? You're looking. What should you be looking for? Yeah, but you don't want to go straight into bang factorize, because there's going to be different forms of factorizing is what I'm trying to talk to you. Karen, you mentioned sum and product, right? But before you go straight to that, there's a couple of things that you should do. First thing is there a what, sorry? Perfect square. That's in it, perfect square, yep. But before you even get to that, is there a CF? Ooh, okay. Common factor, all right? So we want to look for, and I have to say, when you don't pull out the common factor, that's what creates sometimes a very simple problem becomes quite difficult, all right? So the first thing, well, second thing technically, make it all equal to 0. Second thing, is there a common factor? Okay, if there is, obviously pull it out. What's the next thing that you should do? There is a common factor, or there wasn't, bang, you've done it. What do we do next? So we're saying, yep, you pulled out the common factor. I'd be then saying, is, or does it look like, that's an is it, a squared minus b squared. What is that called? Do you remember? That's not a perfect square. It's got square in it. Difference. Difference of 2 squares. Now, if it is difference of 2 squares, who remembers how you factorize difference of 2 squares? Excellent. A plus b, a take b. And we'll put all of this into practice in a moment. And this little process should actually just take 5 seconds in your head, right? You're looking, everything on one side, tick. Is there a common factor? Yay, nay. Pull it out if there is. Is it difference of 2 squares? Very clearly, if it looks like something squared, take something else squared, right? If it is not, there's one more type that you have to look for, and I think that's the one that Dylan referenced. So is it, do you know what a perfect square looks like when it's expanded? What was that? It would be a squared plus 2ab plus b squared. I got to say, I'm not great on recognizing that one. I just go to the sum and product thing. So this is what we call a perfect square. It's cute that you're writing this down. I didn't expect you to, but that's all right. If it is, I think we all know what a perfect square looks like. That's then a plus b all squared. Do we agree? So you've run through, we've pulled out the common factor if it exists. It wasn't difference of two squares. It wasn't a perfect square. What did you say? If it's a perfect square, if it's not a perfect square, sorry, what are you left with? Pardon? The sum and product, that's right. You say product and sum, so I go sum and product, but that's okay. You say product and sum. And what do we mean by that? Well, that's when we have, hey, x squared plus, give us a number, any number, I'll go 14, if that's okay with you. 14, and we'll go 9x. So, what we're looking for, who would like to take over explaining this? How do we factorize that? What are we looking for? Well, we've looked for the common, we've put everything on one side. We've looked, there is no common factor. It doesn't look like something squared takes something else squared. It doesn't look like it's a perfect square.
Like what factors of 9 or 14? What factors of 14 equal to 9?
Excellent. So what factors, so what two numbers times together, that's what product means, right? What two numbers times together give you 14, but add together give you 9. 7 and 2. That's right. Okay. Fascinating. European people don't actually do sum and product. They just always go quad formula every single time. And you might go, well, I want to do that. This is so much quicker. It should take 10 seconds to look and go, oh, can I find two numbers that times together gives me this, that adds to be this? If I can, and you guys have gone, absolutely, it's 2 and 4. So it just becomes x plus 2, x plus 7. Oh no, what I said 4, sorry. And therefore, what are we doing? We're saying, what number can I put in here that will make that bracket equal to 0? Negative 2. Because negative 2 plus 2 is 0. 0 times anything gives me 0. Solution. And what's my 1 from here? Minus 7. Yep. Minus 7 plus 7 gives me 0. 0 times anything is 0. Solved, right? One of my absolute favourite ones to do would be, Ed, Laurie, do you remember what my favourite number would be? No pressure. One of my faves. Hope that one works. Okay, so I like this one because there's lots of factors of 48. And yeah, sure, it's minus. Now, if you're systematic, which we should be because we're mathematicians, right? You might take a couple of seconds to look at it and go, oh, do I know my times tables really well? Yeah, and some of you could actually already see it. Anybody already know what it is? I might have stuffed it up myself, all right? Some people have already got it. If you don't, after 5 seconds, list it systematically. 1 times 48. Does 2 go into 48? Does 3 go into 48? 3 goes into 4 once with 1 left over, and then you get 16. Does 4 go into 48? Does 5? No. Does 6? 7 doesn't. 8 is already there. So there you have, within the space of, I reckon that was 10 seconds, listed all the factors of 48. So now you're looking, triage, and you go, what's the only pair that will give me 13? Yep. Now, in order to get a negative answer, clearly one's positive, one's negative. But when you add them together, you want minus 13. So which one's positive and which one's negative? It's got to, what did you say? Yeah, the larger one is always the sign that's in the middle. And you should find that pattern yourself. But anyway, so it's going to be x plus 3, x takes 16, equals 0. You do a quick check, minus, yes. 3x take 16x. Yes, you get minus 13. Huzzah! We are done. What would be my solutions? Minus 3, positive 16. Is this coming back to you now? Yeah. Okay. So we are now going to get into, okay, very pleasant. Everything is on one side. I'm not quite sure why people are talking instead of ruled up. They've got this already going and they've already started. You hand in hand. Right, so we look. Excellent. Everything's on one side. What's the next step? Is there a common factor? Yeah, baby. What is it? X. So we yank it out. Okay? We check numbers. No, 4 and 7. Nothing common there. So x times what gives me 4x squared? 4x. X times what gives me? Right. Beautiful. And now we go, hey, what makes each of these things? What makes this 0? What makes this 0? So we've got, hey, x equals 0, because 0 times anything is going to be 0. And what my lovely little year 9s are doing at the moment, they're solving little linear things like this. How do you get x by itself? Going to get rid of the times 4 first or the plus 7 first. What do some of them tell me? Get rid of the 4 first, miss. No. So, get rid of the plus 7. You take 7. Get rid of the times 4. You divide by 4. And you do this so often that you go, 1, I could do it in my head. Or you end up seeing the pattern. Right? You always have to divide by this and reverse the sign. Sweet? So I'm getting rid of that. Nobody wrote that down, hopefully. Good. Okay, onward and upward. Next one, let's go. 2x is common. Correct. Pull out that 2x. If I pull out the 2x, can I ask, when you're doing this, are you asking yourself 2x times what gives you 6x squared, or are you dividing through by 2x? Ah, that's good. Common error, a lot of people forget the 1. So always double check what you've factorized. If you expand it, do you get that top line? Okay? Always double check. So once again, x equals 0 is going to be 1. And what's my other? It's positive. 1 goes on the other side, minus third. We're good? Right. I'm going to give you a moment to try and finish 1, and then we'll have a look at 2, because those get a little bit creative. So just taking a couple of requests. So again, this is a great question. I love this one because it makes sure that people do it nicely and they're checking their work, because what are the factors of 6? We've got 1 and 6, and we've got 2 and 3. And as you can see from there, both of those pairs could get you the 5. And this is when it comes down to, I want minus 5. So how could I get minus 5 from these? Would you agree it would have to be minus 6 plus 1? Minus 6 plus 1 is minus 5. And minus 2 take 3 gives you minus 5. Do we agree with that? So doing that, we'd get the sum, but what product do we need? Positive 6, which is the only pair when I times them together will give me positive 6. Negative times a negative gives me a positive. A positive times a minus will only give me a minus. Yeah? So simple, write it down. If you are trying to keep it all in your head, that's where something that should take you 5 seconds will take you 20. It all adds up. So running through, we're just doing I, right? Even if you're not up to it, you might want to listen, but our first check, is it equal to 0? No. So let's get everything on one side. So we're going x squared take 10x plus 21. To get rid of that plus 10x, we take 10x. We happy with that? Right? Happy out? And I like to write it as x squared x and whatever. So now, what are our factors of 21. Systematic, 1 and 21. 2 doesn't go in, 3 goes in, 7 times, 4 no, 5 no, 6 no, 7, got them all. So, what's the only pair that's going to give me minus 10? Yep. And what's a negative times a negative? Positive. So, x take 3, x take 7, equals 0. Sweet? When it gets up to number 2, notice we have a number out the front here. And unfortunately, we sigh, Jazz, because we cannot pull 9 out as a common factor. Coops, Keish, we're listening? So, these ones are a little bit irritating. I'm going to come back to this one in a minute. If we look at number 2, I don't know if your teachers taught you last year about splitting the terms. I can't stand that. I do this with trial and error. So the only way to get to 2x squared is to have 2x times x. Do you agree? The only factors of 7 are 1 and 7. So where are we going to stick the 7 so that we get the minus 13? Don't we have to have 2 7s give you 14? That's going to get you close. So if you know how to expand, this becomes really easy. If you are finding this difficult, that's telling you you've got to go back and practice your expanding skills a little bit. So that gives me minus 14x, agreed? And then we go plus 1. That gives you the plus x, and you get minus 13x. Huzzah, done. This is the moment I tell you some interesting news. It's the quadratic test where you will asked to be doing half of it without a calculator. And so it could be simple things like this. The good news is that they're not going to give you massive numbers. They're going to be small numbers because you haven't got a calculator, because they don't want you wasting time trying to multiply 12 by 15 or something, right? So bad news, but then we have good news. Okay, so they're always going to be small numbers. So we haven't got to the bit where you can use your calculator to do it. Hopefully we know, but if you don't know, that's okay. We'll show you that on Monday. But all good, yep? Oh, it'll be next term. Okay, have a look at this one. We've got 3x squared, take 16x, take 12 equals 0. Now this one we grimace a little bit more. And we go, the only way to, oh, by the way, is there a common factor? Does 3 go into 16? No. So, no common factor. The only way to get 3x squared is to have 3x times x. Agreed? But this one isn't as nice as the previous one because 12 is not a prime number. So to get the 12, well, you could have 1 and 12, you could have 2 and 6, and you could have 3 and 4. This is where I need you to have a little bit of times table skills. Should we consider the 1 and 12? Like, if we have a 1 here and a 12 there, 36 and 1, there's no way I'm going to get 16. What if I had 12 and 1? What's that? 12 and 3. Can I get 16 from that? Do you see how you're doing this really quickly? So you're not even considering that. Agreed? Sometimes you can just see it. Okay? What about 2 and 6? That's 18. That's 2. 18 and 2 give you 16. Now, sometimes it could be like this situation where you have to just check your positives and negatives. So don't just get really excited and go, wow, always double check. So again, how do we get a minus 16? Doesn't it have to be minus 18? So that has to be minus. And minus 18, you want a plus 2. That gives you minus 16. Agreed? Is a positive times a negative equal to a negative? Huzzah. Done. Yeah? For those of you who did splitting the terms and think, no, I like that. I'm happy to go through with that again with you in the double on Monday, because you're more than happy to do it. My colleagues from previous things, we just can't stand it. But that's okay. I'm happy to go through it. There's a place for it. This one, a little bit irritating, because unlike these where this was prime and this was prime, this is now not prime. Is there a common factor? Damn it, no. So the only way to get 9x squared is again to go 9x times x. What are your factors of 4? 1 and 4, 2 and 2. And you look at what we want in the middle. Oh, and what's the other way? So any good with that? 9, 4s are 36. If you put the other way around, no good. 9 times 2 is 18, and 2, that's not going to get you. So how else can we get 9x squared? And again, I'm not spending 5 minutes on this. This is quick. This is less than a minute. So now we're trying for the 12. And you've got it. Short, sharp, shiny. Okay. I'll admit, questions like, what were we doing at the back, girls? Like J, 12 and 15. I mean, come on. Because how do you get the 12x? 1 times 12, 2 times 6, and 3 times 4. So there's a little bit of trial and error. But if you get to that, don't waste your time. I'll be okay. I'm about to kick you 3 out. With 3, same sort of thing. You just have to expand your brackets first and get everything on one side. Can someone tell me with D, how do you do that one? Yep. How do you get rid of the divide by x? You times by x. You have to do these for homework, kids. So please listen. I can see some of you zoning. Okay, so with this one, we're going to times through. You're going to times through by x. What's x times x? It's not 2x squared, it's just x squared. When you times this by x, the divide by x disappears. Equals, when you times 3 by x, you get 3x. So this now becomes a pretty nice one to factorize. So don't get bamboozled and think, oh no, I can't do these. Yes, you can. How are you going to get rid of these? You're going to cross multiply. Hello, girls at the back, can you please listen? When you cross multiply, do make sure with this minus, give it to one of them. Give it to the top, give it to the bottom. Please don't give it to both. Okay? So I just put that up as minus 9. So it'd be minus 9 times all of this and x times that. Do you want me to write that down? You want me to write that down? Right. So can you 3, please, take your stuff and go sit outside the maths office because they want their test back and we want to quickly go through. You're not in trouble. You got really worried then, Coops. So give the 9 to one of them, so it becomes x plus 3. 1 take x equals minus 9 over x, and then we cross multiply. So we end up with x times x plus 3 equals minus 9 times 1 take 9. Expand your brackets, get everything on one side, and away you go.